Okay, this question says that let I equals integration of 5 upon x plus under root 6 minus x. Using the substitution u is equals to square root of 6 minus x. Show that I becomes equals to this. Hence, show that I is equals to 2 ln 9 upon 2. All right, so we need to use this substitution in this integral. First thing we do is change these values of x into u values using this substitution. So when x is 2, we'll get square root of 4, which is going to be 2. And when x is 5, this will be 6 minus 5 square rooted, which is 1. So the lower limit of integral, which was 2 earlier, will now stay 2. And the upper limit, which was 5 earlier, now becomes 1, which is a problem. The lower value should not be bigger than the upper limit. So we'll fix that later. Then we have 5 upon, in place of x, we're going to write, we first get u squared equals 6 minus x. And then when we rearrange that, we get x equals 6 minus u squared. So let's write that. 6 minus u squared plus square root of 6 minus x would be 6 minus 6 plus u squared, which gives under root u squared, which is just u. So we get minus u squared plus u plus 6. And we have limits 1 to 2. Now let's change dx into a du term. For that, we integrate both of these sides with respect to x. So we get du upon dx is equals to half 6 minus x. Power gets subtracted by 1, so negative half times we multiply the derivative of this on the side, which is negative 1. So du will be equals to minus 1 upon 2, 6 minus x, power minus half, and dx comes to this side. Okay, so we will write, in fact, we will also change this x into u. So what will we get? We get a negative half here. Inside we get 6 minus, instead of x, I'm writing 6 minus u squared. And then a negative half here and dx. Hold on, we were supposed to make dx the subject, so I'll have to fix that in a second. So du equals negative half. This becomes u squared with the power of negative half dx, which becomes u power minus 1, which goes in the denominator and just becomes u. So we have minus 1 upon 2u dx. And now we need to make dx the subject. So dx equals minus 2u du. So we write that here, minus 2u du. Okay, let's continue. So now we get 1 to 2. There's a negative sign outside, and we can also bring 10 outside. So we get negative 10. And we have a u here, and we have a du here, and we have a negative u squared plus u plus 6. And we're supposed to show this. So that means, sorry, 10 stays inside. So I'm going to keep 10 inside. Oops, give me a second. So let's keep negative, 10 inside. So a negative outside and 10 inside. All right. Now we need to change this into this. Okay, so first thing we see that the limits here are swapped. 1 is below and 2 is above. That we can easily do by making use of this negative sign. There's a rule in integration that if you have AB and a negative sign with it, that becomes BA. So we're going to get rid of the negative sign and swap these. So now the limits is fixed, and in the numerator we have 10u. In the denominator, we're going to do middle term breaking. Let's do it here. We have minus u squared plus u plus 6. So we're going to write minus u squared plus 3u minus 2u plus 6. Okay, we can take u common and we get negative u plus 3. And here we can take plus 2 common and get minus u plus 3. So we get u plus 2 and minus u plus 3. And that's what we have to show. 2 plus u and 3 minus u. It's the same thing. So let's write that 2 plus u and 3 minus u. And the first part is done. We have used substitution and changed the given format of integration into this form. Okay, part 2 says, hence show that I is equals to that. That means that now we integrate it. Okay, so now we integrate 10u upon 2 plus u and 3 minus u du. Okay. So we will be using integration by parts here. So 10u upon 2 plus u and 3 minus u can be written as a upon 2 plus u plus b upon 3 minus u, and let's solve it. We will make the denominators the same by multiplying a with 3 minus u and by multiplying b with 2 plus u. The denominators on both sides will become the same this way and we can cancel it. So I've skipped a step. Now we can substitute u is equals to 3 and get the value of b. We'll get 30 on one side and 5b on the other side, which gives us b equals 7. So I'm sorry, it becomes 6, not 7. And for the other one, we can take u is equals to negative 2. That will give us the value of a. So we'll get a minus 20 on one side and a times 5 on the other side, which gives us a negative 4. So partial fractions become, let me write negative 4 here and 6 here. Okay. And now we integrate this. So integrate within the limits 1 to 2, negative 4 upon 2 plus u and 6 upon 3 minus u. Okay. This becomes negative 4 ln 2 plus u upon 1 because the derivative of 2 plus u is still 1. What rule did we use here? If it's 1 over fx and fx is linear and you have to integrate this, the result is ln fx upon f prime x. That's what we're using on both the fractions. For this one, it's going to be 6 ln 3 minus u upon negative 1. And the limits are 2 and 1. Okay. So we get minus 4 ln 2 plus u and a minus 6 ln 3 minus u, and the limits would be 2 and 1. Okay, let's substitute the limits. Let's substitute 2 first. So we get minus ln minus 4 ln 4 minus 6 ln 1. Ln 1 is 0, by the way, so this gets eliminated. Then a minus sign, then minus 4 ln 3 and minus 6 ln 2. Okay, now we need to simplify this. So minus 4 ln 4 plus 4 ln 3 plus 6 ln 2. Okay, now we need to change it into 2 ln 9 over 2. Okay, so first let's move all these three coefficients into powers. So we get minus ln. What is 4 power 4? I believe it's 64. No, it's 256. Plus ln 3 power 4 is 81. Plus 2 power 6 is 64. Okay. Now, using the rule of log, we're going to take ln common. The positive values get multiplied, the negative values get divided. That gives us ln 81 upon 4. But they want the answer in terms of ln 9 over 2. So this is actually ln 9 over 2 squared, which becomes 2 ln 9 over 2. And this is what we had to show. And that's our final answer. Yep, 2 ln 9 over 2.